Martin, it's great to have you with us today. Thank you for coming along.
Thank you very much for that introduction. Hi, folks. I'm going to put my slides up. Right. Thanks for that introduction. Yes, I'm going to speak about LEAF today and the intersection between research, reproducibility, and environmental sustainability. I thought I'd start with the good. It's always good to start with the good because I'm going to mention some of the challenges of science in a second. But obviously, science is doing a lot of good. That kind of goes without saying. I probably don't need to say that to this audience as well. That being said, I would argue that science is also under duress when we take a little bit of a step back. Yeah, I put these factors up, which is basically we have the largest workforce that we've ever had in the sciences, which is not necessarily a bad thing, but we also have plenty left to research, and that kind of goes without saying. And I think COVID has highlighted some of the gaps that I wasn't aware of as well in our knowledge base around science. It's also the most competitive funding environment that it's ever been in terms of research. So in terms of accessing the financial resources required to accomplish science, it's pretty tough. That graph there on the right is the lightest way that we can say that we're in the midst of a climate crisis. And I know that since NASA released that data, the line at the end has actually gone up a fair bit. It's now at 420 parts per million, I think. And the point of that I just want to say is that it's going to affect every facet of society, and research and science is no different. There's also another big challenge in science, which is related to all this, which is our systems and our research quality. You know, this is very much the audience that is aware of that. But there's the reproducibility crisis. And, you know, you might have seen this. This was from a little survey at Nature where 90% of researchers agreed that there was some sort of reproducibility crisis, but 2/3 of which thought that they had procedures in place to address this. So everyone was aware of the issue, but they definitely thought it was not quite at home. Now, the reason I'm bringing this up and you know, just sort of give away the intersection of why I'm talking about this is because really, I'm going to show you some quiz questions to try to make it interesting for you. But you know, science is very resource intensive, and essentially, if a lot of that research is not reproducible coming out of higher education, it begs some pretty tough questions about how we're using those resources. Also, I might say that you know, when we're going around and trying to promote good practice around lab sustainability and trying to make it more environmentally friendly, a lot of that is through good practice steps throughout the lab and how research is conducted within the lab. It's not people intentionally doing bad things. And a lot of that relates to how we improve factors around reproducibility and research quality. So this is from that same survey, and just looking at factors that would improve research quality. And really, there's this common ground there, essentially, which is that you know, it's through good practice steps that we would improve both environmental sustainability as well as research quality with labs. And by improving reproducibility, then we should reduce the overall environmental impacts. You know, and the little tagline I was saying is that, you know, sustainable research is reproducible research, and vice versa. You know, if we make the most out of the data that we have, then that represents a good use of our resources. You know, taking the step back, then we have plenty left to research. We have the largest workforce. We're in the midst of a climate crisis, and we have concerns over our methods and a very competitive funding environment. You couple that with the fact that in the UK, you know, the UK government has made the commitment to be net zero by 2050. But it's also said that it's going to massively invest in the sciences. You know, the roadmap for UKRIO to reach, I think, 2.4%, it's up from 1.7% of GDP, and et cetera. It represents a huge investment in the sciences. Those two things can't necessarily go together until we look at the efficiency and environmental sustainability of our science. And so that's why I'm here talking to you today. Something's got to give. Okay, this is a little break, but this is a statue for those who work around sustainability. It's called a statue called Politicians Debating Climate Change, and sometimes it is the sentiment of it. instead of reeling off some facts, I thought I would give you a little quiz, which would highlight and some of the issues and some of the stats. We need a lot more stats around this area. It's a very new field, I would say. But lab plastics were estimated to contribute what percentage towards the global plastic waste in 2014? You don't have to answer it, but you can think about it. That plastic, of course, is not going to be going to that floating island of Pacific trash that we read about. It's typically going to be incinerated at high temperatures. Really interesting piece of work coming out of the US showing that a lot of the clinical waste processing plants that deal with a lot of this waste coming out of research environments are not in affluent neighborhoods, to put it lightly. Answer is 5.3%. A typical new ULT freezer, so that's an ultra low temperature freezer, will consume as much energy in a year as, and I'll admit Americans use more. Fun fact is that your mobile phone uses about as much as a domestic fridge freezer, but not in terms of charging, but typically in terms of server space that's required to power up all the good things that we do on our phones. That answer for a new ULT freezer or a ultra low temperature freezer is as much as a UK household. That doesn't take into account, of course, the extra energy that's required to cool it externally. So not internally, but on a hot day, those freezers, they produce a lot of heat. From the pieces of lab equipment that I've listed in front of you, which consumes the most energy? And then I'll put it into units of houses for you. The answer is fume cupboards. Chemistry labs, we've seen that they have sometimes 100 more fume cupboards operating 24/7, extracting air at high velocities and chucking it out the roof that we've paid to heat and cool throughout the year. And each one of those units will use around 2 to 3 houses worth of energy, depending on how they're set up and how they're used. What percentage of healthcare waste is hazardous according to the World Health Organization? Now, I'll put this because a lot of the labs that we would work with in the name of safety would dispose the majority of their waste through clinical waste streams to be incinerated. And they put the figure at around 15%, but it was to say essentially that I thought there was a lot of scope for how, for reducing the amount of volumes that we put through clinical waste. Obviously that changes depending on what the lab is doing. Between 2007 and 13, the world economy grew by 20.1%. How fast did gross expenditure on research and development grow by? This is the one that when I give the quiz, most folks get this one wrong, actually. The answer is 30.5%, which is pretty impressive when we think about the rate of growth of science and the resources that are required to enable that science. Not all of it, of course, but some of it is quite resource intensive. Research is accounted for what percentage of the world population? And I think that I've seen that research accounts for around 2% of the world's GDP. So I should say as well, we don't really have a statistic on what's the total carbon emissions associated with science, because I don't think that research has been really done yet in an accurate manner. The answer is 0.1%. So 0.1% is having a massive impact in terms of GDP, and we could expect carbon emissions as well. How much does science grow by every year? And this is from, you can see this reference, a very long title. They were looking at the rate of growth of science really in more recent times, as opposed to 100 years ago, although they did look at 100 years ago as well. And they put it at around 8 to 9%. And the bonus for doubling time then was around 9 years in terms of scientific output. I will say as well that you could almost venture that scientific growth right now is at least around COVID is at a capacity around the UK in terms of if people have worked around labs, I'm sure they've heard that there's you can't get a lot of the supplies. Essentially, people are short on a lot of the plastics and etc. And if you speak to manufacturers, I've spoken to some folks at Eppendorf, and they said that their factories are at capacity. They can't produce any more plastic, and they're having to decide and allocate where those resources go to. And that's not necessarily just because of shortages in terms of supply, but also other mitigating factors. But Brexit jumps to mind, but yes, it does show that we're growing this this body as quick as we can, and it's having an impact on the environment. This question I don't have an answer to, but I'd like to ask this question to folks, which is related to the reproducibility question, which is what % of the research you've conducted gets published or is made accessible, essentially? You know, when I used to give this quiz in person, a lot of labs would just say they think 10% or 20%, which in terms of our ratio of what we're getting out of the amount that we're putting into science is a good thought experiment. You know, it pushes us to consider, can we do better, essentially? Can we make more out of all we're investing in this area? Some people did answer higher than 20%, I should say as well. But actually the average I was getting was around 20%, which I thought was interesting. So labs consume around 3 to 10 times more energy per meter squared than typical academic spaces. Most research institutions, you know, when we think about our energy, we think about, you know, residences and lighting and et cetera. But most of the energy, if you're at a research intensive institution, is going towards the labs, typically. You know, at UCL, our figure is around 52%. I also work part-time at King's College, where the figure is more around 60 or 65%. So, you know, if we're going to deal with our some of these institutional net zero targets, we have to talk about the labs. This is a not quite to scale figure, just highlighting what I was mentioning before about the energy consumption of some of these items. I think, you know, the takeaway from this is that we can do a lot around these in-between items right now. The highly specified equipment like NMRs or an electronic microscope, we don't have as much scope in terms of our usage, but these we can certainly do a lot about in the immediate. We can do more eventually about that. Sustainable labs and green labs is quite a broad topic, and it's a burgeoning one. And green chemistry is also growing in recognition that, you know, a lot of the solvents that we produce have pretty high impact into as greenhouse gases. You know, I've broken it up into 3 large areas, and I'm not going to go into too much detail into these and go through advice and et cetera too much today. Although if you're interested, you can get in touch and et cetera, but just for the sake of time. But built environment is really important. You know, it's a very rough figure, but maybe 40% of the carbon emissions are associated with the creation and utilization of the buildings. That's the GSK net zero chemistry building at Nottingham in the photo. There's also what we buy and purchase, which has a large impact. And obviously you don't manufacture a lot of the items that you use, but they have a massive impact on in terms of the environment. And we don't even know how much, because most suppliers just don't measure this. And nobody does life cycle assessments on the overall impacts. There's this other big area though, which really interacts everything, which is what we think of mostly, which is lab operations and science operations, which is how people use their facilities, how they interact with their facilities. Yeah, it's the one that I'm mainly going to focus on. But that being said, I did want to say very quickly on the importance of embodied carbon and life cycle analysis, because we don't look at this. And, you know, I mentioned energy before, but carbon is the real impact, and it's the metric of sustainability. These are some figures from UCL, but you can see that despite the pandemic and a lot of our labs being closed over 2019 and 20, lab equipment was still around 40% of our total carbon emissions in terms of what we buy, and 83% of the total carbon emissions of the institution come from these items. Basic takeaway, even if you're not interested in lab sustainability, is often people will promote you know, replacement of items for more efficient items, but they don't take into account the full life cycle analysis. So if you replace a functioning fridge at home for a more efficient one, and that fridge, you know, the old one still has life in it, typically you're resulting in more carbon emissions because of the amount of carbon required to manufacture these things. And it's just a general tip to be careful, because there's a lot of green initiatives out there that are essentially driven by marketing. And if they're not doing those life cycle analysis, there's sometimes a reason for it, but it's it makes it almost impossible to know when is the right thing to do. the other example people say is, should we use single-use plastics versus reusing items? And generally from the work I've done, very quickly, I'll just say, yes, reusing items on site is better. Anyways, there's a lot going around sustainable labs. It's a very broad topic, but most big research institutions are now looking at sustainable lab programs. And as you can tell, my focus is sustainable labs, but I think what we need to do is to integrate this more systemically into science. And one of the ways that we're doing that is to integrate it with reproducibility and research integrity and quality. So, the reason that I think a lot of this stuff is not commonplace today is because it's not standardized. We haven't made it easy, and it's not necessarily integrated into funding mechanisms as well. The tagline is, there's a reason we all follow health and safety practices, but we don't, sustainability is not necessarily pushed, and one is voluntary and one is mandatory. And one is, systemized, and one is, you have to go and figure it out yourself. And so that's when we thought we need to create a standard around this. We need to make it sort of like Athena Swan and gender equality, and so that it's common practice in science. And we need to help the funders as well know what a sustainable lab or green lab might look like. Or what science operations overall. It doesn't have to just be in the lab, but in working in this space, sometimes I use the word lab, but I think it's really sustainable science is actually the bigger, more comprehensive term here, because a lot of work, for example, takes place in data centers today that yes, have very large impacts. The direction that we're going to is comforting in the sense that UKRI in particular have in working with NERC, have put out an environmental sustainability strategy last year, which I'd encourage you all to have a quick look at, but it includes putting targets around this for funding recipients eventually. So I think that's matching what a lot of institutions are doing with net zero targets as well. But we need the tools to be able to achieve that because it's not necessarily clear how we're going to do that. But I think part of the solution in that is, again, to integrate research integrity within these sustainability schemes. So that's why I have developed LEAF from UCL and with a great team there. And it's essentially a standard in sustainable science operations. It's got criteria in some of the areas that you might expect, like ventilation equipment, et cetera. But it's uniquely got some criteria on research quality. And in developing these criteria, we were assisted by UKRN, where I shared around some of the proposed criteria, and the folks that were interested were very kind enough to give some feedback on those criteria. The criteria are broken up into bronze, silver, gold, and crucially, LEAF is a user-led initiative. There's no funding from private companies or suppliers, and et cetera. For fun, we've added on some calculators that allow people to estimate the carbon impacts of what they do, essentially. That's in recognition that actually, when you integrate environmental sustainability within the sciences, some people think of it as an additional cost, but actually we recognize that people were saving a lot of money. I think that relates back to the previous point about embodied carbon, is that replacing everything immediately for a more efficient version isn't overall typically more sustainable because of the embodied carbon of things. So in that respect, using things and reuse and et cetera, and other sort of things that you can do around lab spaces means that you save money, you save carbon, and so that's a good headline to emphasize, and that's why we put those calculators in there that are discrete calculators that focus on the areas that we can easily quantify and are high impact. I wanted to give you some example criteria because people often, these aren't all the criteria, but it's some of the ones that I thought are worth highlighting, because people say, how can you put a criteria around this, and what does that mean? How do you promote research quality? The criteria that we have, a very basic one is your calibration of units of measurement. So your scales and pipettes. And the example I'll give there is that one of the labs I was working with said, oh, we don't want to do that. That might change our results. And that was an indication that it was a potentially useful criteria. there's providing a forum for the sharing of negative results. And I've changed that the wording to really mandating a forum, in the sense that we recognize that failure is not always that accepted in the lab. And I used to work in a lab where I was quite afraid to make a mistake, and that led to me not troubleshooting it as much. So, you know, for example, we asked that at the end of all talks, there's a mandated part where people discuss what went wrong. You know, it's not an optional thing that you know, you discuss if you feel like it. Ensuring common protocols are shared, that's pretty you know, straightforward, etc. And the promotion of core facilities. You know, so people don't buy large pieces of kit and think about using some of the companies or core facilities that might exist in their institution that improves the reproducibility results. It's, you know, it's those facilities will have better throughput. So, you know, overall, that's sort of a win in this space. And one criteria that we were thinking of adding was essentially, has the lab sought to make use of existing data? And really, you know, one of the things that's I might ask the audience here is that if you're interested in this area, we're pretty open to input. So, you know, if you wanted to get suggest any criteria, or if you want to look at the criteria that we have that are related to reproducibility and research integrity, there's a few more, but it's sort of an open call to get involved, and yeah, to see if it's something that you know, can assist. It's not my area of expertise necessarily, but that's why we're here to ask for assistance and to engage folks on that. Very quickly, I'll you know, just say that LEAF has a lot of supporting guides and resources in this space. And if you have an initiative that you think is worth highlighting around research integrity, then we can highlight in LEAF because a lot of institutions are using LEAF now. And it's going out to a lot of labs. So it's a good way to highlight good practice you know, initiatives in recognition that LEAF isn't going to solve everything around research integrity and reproducibility. But we can highlight it in the criteria that are relevant. Before getting LEAF online, we piloted it for 2 years in 23 institutions, mostly around the UK, but also one in Ireland. Headline figures being that they saved carbon and saved money, and that people thought it was a nice process that they would use again. LEAF is now available online, and there's a few institutions that are have gone for 100% uptake. As I mentioned, the criteria around research integrity were supported by the UK Reproducibility Network. National Technician Development Center have been supportive of this in recognition that technicians are often the forefront of using lab spaces. And this has actually gone up since I made it, but we're just about at 30 institutions now, mostly around the UK, but several institutions in Australia and around Europe that have signed up as well. Honestly, it's been a fantastic uptake since launching, and it's just about the time to keep up with folks to you know, get them using the system, which is great. So it's been really positive feedback, and you know, again, I think it's for that reason that if you want to highlight an initiative that you're doing around integrity, it's a call out for that you can highlight it through these criteria, because a lot of people are going to be using this, and hopefully more. Again, you know, I put the funders there because I think one of the goals of doing LEAF is that eventually it's a tool that you know, funders could look at to integrate within their funding mechanisms to help promote this type of work. And so, you know, that was the original goal in some senses. So I think they're definitely looking at this area now, and excited to see where it goes, really. How does LEAF work? Register your institution, choose your criteria, work through them, submit. And then there's some guides that assist folks on that if they're interested. And I mean, I'm not going to go through this, but it's just, you know, a few screenshots essentially of the tool and the criteria and et cetera that have supporting guidance. You know, there's links there if you like, and you can tailor the links. That's a joke one, watching music. I shouldn't have put that there. But yes, you can tailor the links and et cetera. For your institution, and you can document and use the calculators that you wish to estimate things, and we can add calculators as we go. We're looking to eventually add some for procurement things like single-use plastics and etc. But we're not there yet. So yeah, It's usually some advice on people that are interested in getting this going. I think it's really good to integrate sustainability and reproducibility into the labs and science spaces that you work. Create green lab groups, green science groups, or make it a standing agenda item on existing networks, just like health and safety often is. We want to embed this so that it's common practice. Yeah, you can read through those, but essentially it's if you're interested, then we've got some guides on this. Last slide I'll say really is to question standards and to consider introducing new ones. Before I told you that each -80 freezer used as much energy as a house. They used to all be run at -70, and that 10-degree difference is about a 25% energy consumption difference for something that uses as much energy as a house. And that standard was seemingly pushed along by freezer manufacturers, as opposed to there being some large comprehensive study that I can find that says that -80 is a better temperature. So that was a study I set up years ago at the University of Edinburgh at Roslin Institute, which to my knowledge is still ongoing, but I'm not personally involved in it anymore. But it was supposed to look at sample integrity over time at 3 different temperatures of -60, -70, -80 to help sort of challenge the current temperatures that we use. And on the right there is Martin Howes, who's a green lab specialist at University of Cambridge. And he was looking at how plant growth facilities were all using old mercury arc bulbs and halogen bulbs. And he set up a study to essentially look at LED lighting as opposed to the old systems, in which he was able to convince researchers that LEDs, after mapping the wavelengths, were about the same as the old bulbs, and to get them to replace and save huge amounts of energy. That's it for myself. A lot of thanks, including to the hosts and everybody who organized this event, James and Alicia. And if you want to find out more, you can drop me an email, or you can check out the UCL website on Leaf. We've just gotten it online since February, so we've got more work to do, but we're encouraged by this space, and also encouraged by the feedback of folks who have around its integration with research quality. So that is it for myself, and thank you very much.
Martin, thank you. That was fascinating. It's looking at the questions and comments in the chat. It's really struck a chord with the people attending today, and we've got an awful lot of questions and fascinating comments, which we'll move straight on to before we go to the panel discussion. One question from the chat: many organisations have quite old buildings and lab structures that would find it difficult to sort of accommodate some aspects of improving sustainability, criteria such as ventilation. I mean, aside from sort of committing to major kind of infrastructure renewal, how can institutions work around perhaps sort of limitations of old architecture to move towards some degree of better sustainability, do you think?
Yeah, I mean, I think I will say that the building definitely has a large impact in terms of the energy consumption, but the operations still can be greatly affected through things like the criteria in Leaf. So looking at your throughput of plastics and etc. And we can't solve it all, but I'd say that you could still have quite a large impact overall on your carbon emissions by integrating some of these practices. And we've written some guides on, for example, Sustainable Consumables Guide, to try to inspire scientists taking good practice from around the sector, what other people are doing to reduce and save in that space. So I take that into account, and it's a very fair point, but yes.
Thank you. You mentioned a guide to sustainability. That's kind of question from peers who ask, are there alternatives to single-use plastics for molecular biology, sort of tubes, pipette tips and the like, that sort of thing that you're aware of?
I mean, I will say that a lot of labs that initially told me that they would never reuse an item, once there were shortages on items, found a lot of ways to reuse items, which was sort of motivating. And they also found that they were saving on costs. And I know that there's more labor involved sometimes, but there's not a silver bullet there in terms of all the items, and it depends. And 96 well plates, I don't really know of an alternative. But Falcon tubes, yes, you can go back to glass and etc. You can reuse the plastic ones as well. But again, that's consolidated in the consumables guide that we have on the UCL and linked in through Leaf.
Brilliant. Okay, yes, the links in the final screen of the presentation, which is out there, will put some links in the chat as well. In terms of changing behaviour, well, a question from Nicola, what do you think will be the most sort of effective means? A sort of cultural change, a degree of sort of compliance and bringing in kind of rules and perhaps sticks and carrots, or a mixture of compliance and culture?
I mean, I'll definitely say both, because it sometimes in trying to push Leaf around, sometimes I wonder if it's the tool itself that's helping, or the culture change that's joining it, you know. But that being said, I will say that within the institutions, there's such a high turnover in labs and et cetera, people come and go, that I do think there has to be an element of pushing it from above, because, you know, we reach sort of a ceiling sometimes in the institutions that we work of uptake of these programs until senior management or until funders start to support these things. So I think it's definitely a marrying of the two in between. So yes.
Thank you. Philippa asks, is the online calculator for energy consumption available for external users? Is it publicly accessible?
No, I mean, it's embedded within the tool. So it's embedded with the tool. So it's not available just outright on the website that you can use, but yes.
Thank you. I mean, this is another question. Where was it? Joseph asks, given how important sharing as much data as possible on open repositories is for reproducibility, are you aware of if there's been any research on the carbon footprint in relation to data storage, and how might that compare to lab carbon footprints?
Yeah, I think data servers are around 2% of the world's carbon emissions, if I recall, which is comparable with flights, actually. I think flights are around between 2 to 4% of the world's carbon emissions. Data servers are certainly a very large impact, and you know, if you're curious about this, there's something called a PUE factor, which is essentially, I think, the efficiency of how your servers are running in terms of energy consumption. There is a criteria in Leaf that looks at trying to consolidate data so that you minimize the impacts of your data server utilization, which came from some IT experts that it wasn't my background, but there has been, I'd say, more work on data server overall emissions as opposed to science emissions in total thus far.
Thank you. Are you aware of any opportunities or funds available for institutions to sort of seek improvements in this area? And actually, another question, have there been much engagement from funders with your initiative?
The funders have been increasingly supportive of this, and we've rolled it out to some of the NERC facilities this year. So British Geological Survey have used it. They took part in the pilot, and British Antarctic Survey are rolling it out. And we've been in some of the MRC institutes. So you know, I'd say yes, increasingly, and we've presented this to Wellcome Trust, and they, you know, initially, you know, has been supportive, and I'm hoping there's more to come, really. But in terms of funds accessible, it depends what you want to do with them. If it's infrastructural changes, there's a government fund called SALIX, but that's more about building upgrades. So if you can, it's an energy fund. So if you can get a 5-year payback, then institutions can access those interest-free loans to accomplish that. But there have been more government grants from BEIS about this area, although they were surprised at the number of people applying for them at once. So there was it maxed out, is my understanding, but there should be more soon.
Thank you so much. That was a fascinating talk.